Hi, and welcome to the Thursday video. These are the questions that we went over for extra ticket 4.1 and 4.2. So in part 1, which was an optional video to watch, I also reviewed what we covered in class on Wednesday. If you find this helpful, so you can take a look at what we covered on Wednesday, but you don't have to. All right, so what did we do in, what were the questions that we went over? So after folks took the extra ticket, they identified problems 10, 12, 13, 14, and 15 as the ones that they wanted to go over, and that's what I'm going to show you here. So question 10 involves a combustion reaction. So combustions, in this case, it's a hydrocarbon combustion, so something with hydrogen and carbon. Reacting with oxygen to produce CO2 and H2O. And in question 10, it asks, I think, what's the coefficient in front of H2O? So you want to balance it first and find the coefficient in front of H2O. Now, I am not doing the problem that you see in your exit ticket. I'm doing a similar problem. So you're going to use what you see here to help you with question 10. This is not question 10 exactly from the exit ticket, it's just a similar problem. All right, so to balance the reaction, that means that we want to have the same number of atoms on both sides. We're going to start by tallying up our atoms, carbon, hydrogen, and oxygens. Carbon, hydrogen, and oxygen. Okay, so here on the reactant side I have 4 carbons, 10 hydrogens, and 2 oxygens. On the product side, I have 1 carbon, 2 hydrogens, and for my oxygen, I'm going to do 2 plus 1, which is 3. All right, so I look at this, I know it's not balanced because I don't have the same number of atoms on both sides. So remember with combustion reactions, we want to balance, the key is to balance the oxygen last, and the reason why we do that is because oxygen is found in more than one molecule on, in this case, the product side. So whenever you have an atom that's found in more than one molecule, you want to typically balance it last because it just makes your life easier. Okay, so starting with the carbons, I have 4 on the reactant side, I have 1 on the product side. Well, what I want to do is I want to have the same number. So I'm going to go to the side that has the least number of carbons, all right, which is the product side, and I'm going to ask myself, well, what coefficient could I put in front of CO2, since that's the molecule that has carbon in it, to get it to balance? And the answer to that is 4. Now, the reason why the answer is 4 is because when I'm trying to figure out the coefficient, I'm asking myself, looking at the number of atoms I have on the side that I'm going to change the coefficient, 1, so in that case it's 1 times what will give me a coefficient of 4, which is what I want. I want to have the same number, sorry, not coefficient, but value of 4. I want to have the same number on both sides. So I figure out what do I multiply the number I currently have with to get to have the same number on both sides. In that case, it's 4. Now, when I do that, this molecule has not just carbon in it, but oxygen in it as well. So I need to make sure I also change my number of oxygens. So I'm going to do 4 times 2, I have 8 oxygens now, plus the 1 from the water, which gives me a total of 9. So now I have 9 oxygens. Okay, so my carbons are looking good. Let's go to my hydrogens now. Here I have 10 on the reactant side and 2 on the product side. So once again, I need to figure out what coefficient I'm going to put in front of the water in order to get it to be the same. And the reason why I'm doing it in front of water is because this is the side with the least number of hydrogens, and coefficients multiply, right? So I'm going to add put on coefficients that will multiply to get both sides to have the same. So I'm asking myself 2 times what will give me a value of 10. And in this case, the coefficient is 5, right? So 2 times 5 will give me 10. So I want to change the coefficient in front of water to 5. Now, once again, when I do that, I change the number of oxygens. So let's count it again. 4 times 2 is 8, plus 5 times 1, which is 5. So 8 plus 5 will give me 13, okay? Now, I just want to pause for a second. One of the common errors with this is that a lot of times what people will do is instead of just recounting the number of oxygens, they'll say, oh, I had 9 here, I put a 5 in front, so 9 plus 5, and I have 14. You don't want to do that. You actually want to go back and count, what you're doing, because remember you already had 1 here, so the number of oxygens that you increased it by was actually 4 when you changed the coefficient to 5. So just go back and just count it. It just makes it easier. So I just counted again. 4 times 2 is 8, 5 times 1 is 5, 8 plus 5, and got my count. All right, so now that I have that done, the next thing I want to do is go to my oxygen and figure out those coefficients. So in this case, I have 2 on this side and I have 13 now on the product side. So now I'm going to go over here and change it because this has the least number. So asking myself 2 times what will give me a coefficient of, or a value of 13? And the answer to that is 6.5. So 6.5 times 2 will give me 13. Okay, so that's the value that I have now. It's 13 oxygens on both sides. All right, now I'm looking at this and I go, okay, I'm done. Well, not quite, because remember you can't have a decimal as a coefficient. So what we're going to do is we're going to multiply this by 2, because that's the smallest number we can multiply the coefficient, the 6.5 by, to get it to be a whole number. All right, we want to have all whole numbers here, so I times it by 2. But just like in math, whatever you do to one side, you have to do to both sides, or whatever you do to one term in an equation, you have to do to all the terms. So we're going to do that with this. So all the coefficients are going to get multiplied by 2. So over here I had an invisible 1, so that's 1 times 2, 6.5 times 2, 4 times 2, and 5 times 2. So when I go ahead and rewrite this, my final balance equation is going to be 2 C4H10, oops, C4H10, that's a 10 there, plus 6.5 times 2 is 13 O2, goes to form 4 times 2, which is 8 CO2, plus 5 times 2, which is 10 H2O. Okay, all right, so this is the final balanced equation. Now the problem that you have in your exit ticket, it's not the same exact one, it's similar. And the other thing I will say about balancing combustion reactions like this, you don't always need to multiply it by 2. In some cases, when you balance the oxygens out, you don't have a decimal number here, in which case you won't multiply it by 2. So you only multiply by 2 if you have a decimal. All right, in the next video, I'm going to go over problem 12.